Welcome everyone, my name is Maitresh. I am going to give a brief seminar about the topic called error detection and correction codes. Let us see what is error detection codes. The error detection codes are nothing but addition of number of bits, extra bits or known as residual bits to the original data through which we can find errors during transmission or during receiving the data. So let us see a technique of error detection code. This technique is known as parity code. Parity code is nothing but addition of extra binary bit to the group of data through which the number of ones should be odd or even. So as we can see from this definition, the parity bits are used to compare the specific operations to find the error in the data. So let us see the different kinds of parity codes. We have even parity code and odd parity code. So let us see what is even parity code. An parity bit added to the binary data stream which has total count of ones is equal to even number. So let us see an example. Let us see an parity code of 1011. In the data we get, if we count the number of ones here, it is equal to 5. So the number of ones is equal to 5 means, which means it is not an even parity. It should be even number. So we shouldn't decrease. Main important in codes we shall never decrease. We have to add extra bit. So the addition of extra bit should be 0 or 1 as it is binary system. So we have to add 1 to get 6 number of ones. So we will add 1. So after we add 1, the transmitted verb we will get is this. So let us see what is odd parity. Odd parity is reverse of even parity. Here the total number of ones in the original number or the transmitted number should be equal to odd number. So here for example we have this original code. After we count it will be 3, which is an odd number. So the number of here is odd parity. So hence it satisfies. So now the ones counted during the transmitter is equal to 3. So confirm it is odd parity. So we will not change it anything, or we will add a 0 to the original bit to verify to maintain the parity, which is odd parity. So let us see the next one, that is error correction codes. Error correction codes refers to the technique employed to detect or rectify the error. So here we will have two kinds of sections, that is error detection and rectification, which is also known as encoding and decoding of errors. So we will correct this with the help of Hamming code. Hamming code is an error correction technique that adds an extra parity bit to the original data to detect or correct the errors that occur during the transmission or storage of data. So let us see an example of Hamming code during transmission of data, which is also known as encoding. So first step we have to use, let's just take an example. We have the data 1011. Here we have 4 original bits. So the original total number of binary bits is equal to 4, where n is equal to original number of bits transmitting. So here we have to form a formula to find the parity bits. We have to add, to find the number of parity bits we have to formula this m plus k 2 power k m plus k plus 1. We have to follow this formula. The formula, if we substitute, where k is equal to number of parity bits we have to add to the original data, and m is equal to number of bits present in the original data, and k is as we already know. So let us substitute the things. So if we substitute k is equal to greater than equal to 5, means 4, the m is equal to 4 plus 1, that is equal to 5 plus k it will get. So if we do the error trial and error. So if we put k is equal to 1, we will get 2 power 1 is equal to 5 plus 1, that is equal to 6. 2 power 1 is equal to 2, which doesn't satisfy the condition greater than equal to. So let us put k is equal to 2, that is equal to 4 greater than equal to 2 plus 7, which is also not satisfying the condition. If we put 2 power 3, that is 8 greater than equal to 5 plus 3 that is equal to 8. It satisfies the equal to condition, hence the number of parity which we have to add is equal to 3. So there is another formula, the total number of transmitted bit that is equal to m plus k that is equal to 4 plus 3 that is equal to 7. How we are going to find it? So it will be like this. We have to write the numbers. We have to add the parity bits only on even places or 2 power n places. Remember that this is very important. So we have to where n is equal to 0, 1, 2, so on infinity. Okay, then we will have like this. We have to put 1, 2, 3, 4, 5, 6, 7. Then in 2 power 0 that is equal to 1 p1 parity bit 1, and 2 power 1, 2 power 2 we have to add parity bits in these places. So how do we find the parity bit in these places? By checking the parity bits in respect to position. For example, let us see check the positions 1, 3, 5, 7. How do we get the positions? How do we get the positions means we have to the parity bit positions like this 2 power 1, 1. So as we know, for rank code 1 we will get 0, 0, 1, 0, 0, 1, 0. It is equal to 2, like that we will code like this. So here if we see the parity bit positions, we will get ones in p1 places in 1, 3, 5, 7 positions. So we will verify 1, 3, 5. For p2 if we verify, we will get parity bits position 1, 3, 6, 2, 3, 6, 7. For p3 we will get the positions 4, 5, 6, 7. We can verify like this. Let us check how we find p1. So let us check 1, 3, 5, 7 positions. 1 we have p1, 1 we have p1, 3 we have 1, 5 we have 5, 1, and 7 we have 1. If we put the positions, we are verifying for even parity. So here it should be total transfer is equal to even parity. So here we will get p1 1, 1, 1. So we have only 3 ones. We have to add p1 is equal to 1 to get the even parity. So p1 is equal to 1. So we will similarly check for the next p2 position, that is 2, 3, 6, 7, that is p1 1, 0, 1. So we will get already 2 ones, so we don't need to add extra parity. If we add extra parity, it will be odd parity. So we have to add p2 is equal to 0, that is it will be even parity. So let us check the last position p3. If we check p3, we will get 4, 5, 6, 7 places. So in 4, 5, 6, 7 if we put the data, we will get something like 7, 1, 6, 0, 5, 1, 4 p3. So we will get this. If we see this thing, we will already getting 2 ones which is equal to even parity. So we will get p3 is equal to 0. So if we substitute parity 1, 0, parity 1 is equal to 1, parity 2 is equal to 0, parity 3 is equal to 0, we will get this. So the final transmitted bit we will be having is this 1, 0, 1, 0, 1, 0, 1. That is the transmitted code we are giving with the help of Hamming code. So after transmitting the data, we will receive the data. Due to noise, our data is changed. Let us see what is the data we are getting. So the data we are getting is this. So we have to apply the decoding form of Hamming code to get the original data. So how do we find it? So here is the data we get. It is 1, 0, 1, 1, 0, 1, 0, 1. So we have to use the Hamming code. Let us put this one in this in respect to positions. So as we know, the parity code positions are 1, 2, and this. So we don't have to follow that condition. We have to find step by step. So for first one, let us see the parity 1 position 1, 3, 5, 7. So let us see 1, 3, 5, 7, that is equal to 1, 1, 1, 1. It is even parity, so we check whether the number of ones is equal to even or not. It having 4 ones which is even parity, so C is equal to 0. So let us see the next, that is parity 2, that is 2, 3, 2, 3, 6, 7 positions, we will get 0, 1, 1, 1. It is even parity. So there isn't some error in here. So we are getting for second parity. So we will add c plus 2. So we will get 0 plus 2 is equal to c is equal to 2. So let us see, verify for third parity with 4, 5, 6, 7. 4, 5, 6, 7 we are getting again odd parity. So we will add 4 to the error code. So after we get 6, so there is error in 6th position, hence we have to change the bit in 6th position when the original transmitted code is 10100101. So if we remove the parity bits, we will get our original code. So the parity bits here are in positions of P1, P3, P2. So these are the parity bits we have to remove. So after removing the parity bits, we get 0, 1, 0, 1, 1. So the original data we send is 0, 1, 0, 1, 1. This is how we do encoding and decoding of parity bits. So let us see some applications of encoding and decoding and Hamming code. So using Hamming code is very helpful. It is helpful in computer memory, embedding processing, modules, and nanospace satellites. So it can also be used in medical field as is shown in the diagram. So here we scan the brain and compare it with the normal healthy brain. So here, whenever there are some misexpressions or some kind of errors, we can use the Hamming code to detect the errors and obtain the given data like this. So this is how the brain scans take place and errors are found during the medical respective fields. So how do we use them? The Hamming code are crucial for error correction codes in TV broadcasting to ensure the received signals are good and very good. So in satellite communication is used during the communication of data in satellites. It can be used in wireless cellular networks like transmission of data is a better example. In medical field, it is used during the MRI scans, CT scans, accurate data transmission for vital or correct diagnosis of diseases. Thank you guys. In this session, we've seen the importance of error detection correction codes in respective fields. It is very fascinating to know that this simple kind of mathematical application has been using in medical from ground for human health to the space exploration. So we can say that the uses of bits may even more increases in the future. I hope you learned something new. Thank you.